All right, let's do this. We're going to combine all of the tests and intervals that we have done so far together. And so, what that means is you are going to first have to learn how to identify number one, is it a proportion or a mean problem? Okay. What kind of data is it? Categorical, where we have a proportion of something, or is it quantities, numerical amounts? Okay. So that. And then we have to be able to identify, is this a confidence interval or a test? All right. So without the problem saying something such as create a 95% confidence interval, it's just going to ask you a question and you're going to have to decide, is an interval what I need to do for that, or is a test what I need to do for that? So here we go. First and foremost, let's kind of talk about categorical data, proportions versus means. Okay, our unit 7 was proportions, our unit 8 is means. Now, types of things that would be categorical are things such as, you know, do these people, you know, let's see, the number of people or the people that stop completely at a stop sign, okay, or the people that, if you're counting the people that wear a seatbelt at when they go through the stop sign, you're seeing which ones, what count of them. So it's a proportion of a total because I'll be saying to myself, yes or no, that person is wearing a seatbelt, or yes or no, that person came to a complete stop. So that's a categorical amount as opposed to something quantitative like the number of people in the car. And we would count how many people are in the car and find out on average how many people are in cars that come to this intersection. Okay, so keep in mind, the way that the question is asked and what kind of data it is. All right, then we're going to want to look and see if we have got an interval, if we're going to get an interval or a test. So let's take a look at what we have here. With an interval, you are going to be estimating an amount. Okay, so we're going to find that on this exercise, it's not going to say create a 95% confidence interval. It's just going to say how much or how many do you expect. Okay, so we are estimating an amount for how many things we expect that to be. Okay, and so then we'll get our point estimate and then that margin of error to make our estimation with the range. Now, take a look at all of these symbols and stuff here. That looks kind of confusing and a bit scary. So let's see. Okay, so for our confidence intervals, we've got the different kinds of things for proportions. Okay, so we have a confidence interval. So these intervals, these are all starting with the CI for confidence interval. Confidence interval for a population mean, so we're estimating an average or a population proportion. So that's one mean or one average, one proportion. Okay, but we could also do two independent means, like the um, the average GPA for men and the average GPA for women. Okay, so we could have two independent means, but what if we have paired data? So means can be paired, proportions cannot. Okay, so that's interesting. Only means can be paired data. So that could be like the uh, the switch hitters that come to the plate. They hit on both their dominant side and their non-dominant side. How do those compare? So it's one hitter, dominant side and non-dominant side. Okay, paired. Or the confidence interval for two separate proportions. Okay, so we're going to estimate those things. All right, now let's talk hypothesis test. So this is typically something that we are finding evidence of about a claim. We are wanting yes or no decision about something is better than this, or is there a difference between this and what we think it is? A yes no decision about how something is comparing yes or no. So we'll have those same kind of things up above, but we'll start with HT for hypothesis test. So we could have hypothesis test for one mean or one proportion. Okay, we could have the hypothesis test for two independent means. Is there a significant difference between the average GPA for men and the average GPA for women? Paired data, again, these are for means, and then two proportions. Okay, so those are all those things. Let's now do a couple of these together and see how we do. So, the average cholesterol level for people in their 40s is 192. So actually what's going through my mind is, ooh, it said the word average. I like that. And oh, we're talking about 192. That's a numerical value. So I'm already at this point thinking, what kind of data do we have? Do we have proportions and categorical data, or do we have means and quantitative data? So I'm already kind of thinking about that. All right. You are interested in seeing if the average cholesterol level is different for vegetarians in their 40s. Okay. So we're seeing if there is a difference. Doesn't seem as though I'm estimating how much more one is than the other, or how many do I expect to be doing something. Okay. Is it different? So I'm thinking maybe this is a hypothesis test, but we'll see. 56 vegetarians in their 40s were tested for cholesterol level. Okay. All right, so I have just one sample. So that's also something that goes through my mind. So this is going to be one mean or one proportion. Because I think this is the type of data this is numerical. It's quantity. So I think it's one mean. Okay, and then we're going to be comparing the results of one sample to a previously claimed amount of 192 to see if there's a difference. Yes or no, it's the same, or, okay, well, of course, you can't say yes, it's the same because we're not allowed to say the null is true. But do we have evidence that it's different or not? Okay, so that's the thinking process I go through to determine, I'm thinking this is a hypothesis test, not an interval, for one sample, and it was for means. So I'm going to go with HT, hypothesis test for one mean. Okay, let's try another one. I'm going to try a few of these with you, and then I'm going to let you try some on your own. So here we go. Are the sliders at Sierra at Tahoe Ski Resort more likely to spend the night in the basin than the sliders at Kirkwood Ski Resort? Okay, so 50 Sierra at Tahoe sliders and 50 Kirkwood sliders were surveyed. Okay, so I see two different samples. So I'm already thinking it's two means or two proportions, because I also see those 50 at Sierra at Tahoe are different than the other 50. So two independent samples. Okay. Is one of them more likely than the other? So I'm thinking I'm comparing them to see how they compare to each other. I am not saying, it's not saying how much more likely is one to spend. It's not asking for an amount. So it's not asking to estimate an amount. How much more likely is one than the other? So I'm thinking it's not a confidence interval. I'm pretty sure I'm going to be doing a hypothesis test to see if this one is more likely than the other, if I have evidence of that. Okay, so I'm down to a hypothesis test for two samples. Is it a mean or a proportion? So we're talking about spending the night in the basin. So what kind of data is that? When you get 50, what are you going to be saying about those 50? What proportion stay in the basin at night or, go home? So are they just commuters or are they staying there at the resort? The proportion. So I'm thinking, let's see, hypothesis test for 2 proportions. Yep, there we go. Okay, let's do one more, and then I'm going to let you try a few of these. How much more effective is putting an infant in a baby swing to stop crying compared to just talking to the infant? 500 crying infants were put into a baby swing, and 300 infants were just talked to. Okay. How much more effective? So, a couple things. So, I'm estimating how much more was one effective than the other. So, what is a numerical difference between those 2 samples results? Okay, so I think I got a confidence interval I'm going to be making. Now, if it had said, is this one more effective than the other? Is this one more effective than the other? Then I would be saying hypothesis test, but I think I'm going to do an interval. Do you need keys? Okay. So I'm going to be doing a confidence interval. Okay. Now I got 500 crying infants to put in the swing, and this is then different 300 to put in the that are talked to. So 2 independent samples. Okay. Now, so we're down to confidence interval for 2 samples, but is it a mean or proportion? So let's see. We are going to get them to stop crying. That means they're going to stop crying or not. So I'm going to say, what proportion of those 500 stopped crying? What proportion of those 300 that were talked to stopped crying? So I'm going down with a confidence interval for 2 proportions. Okay? I think, oh yeah, this is a tricky one. So I'm going to do this one with you before I then give you a few to try on your own. All right. So, do men spend a higher percent of their free time outdoors than women? Okay. So, I'm not asking how much more time do they spend outside? So, I don't need a number. I'm not estimating an amount. I'm just saying, do they spend a higher percent of their time outdoors, men, than women? Okay, so do they spend? So, yes or no, do they do this? That is going to be a hypothesis test. Okay. And we have 95 men, 95 women. So we have 2 independent samples. Okay. All right. So it's a test for 2 groups. Now, here's the thing that's tricky about this problem is that it says the word percent. So my students go, bam, it's a percent. It's a proportion problem. But not really. I want you all to think, what percent of time of a day do you spend outside? Okay, so you're gonna think of a percent, you're gonna think of a percent, you're gonna think of a percent, you're gonna think different. Everybody's gonna have a percent in mind. And what am I gonna do with those percents for the women? All those 95 women have a percent. What am I gonna do with that? I'm actually gonna average those percents. That's a numerical quantity. So that percent is a quantitative measurement. Yeah, that one's a tricky one. So it's not like do you go outside? Yes or no. So the proportion of men that go outside, it's not that. All right. So the data type is actually quantitative. We're going to be averaging the percent. So what are we down to? Hypothesis test for 2 independent means. Okay. All right. So I want you to pause right here, and then I want you to try some of these on your own. So let's see if you can do number 5. Let's do 5, 6, 7. 5, 6, 7. Do 3 more and pause, and then we'll see how you do. Okay, so pause. All right, let's check and see how you did. Here we go. Ooh, how much more often? I think that's going to be an interval. Ooh, I got 2 different independent groups. Looks like 85 men and 73 women. Okay, so interval for 2 samples, but let's see, what is this? What kind of data is this? It's talking about ordering dessert. So let me think. That's going to be like, of those 85 men, what proportion of them ordered a dessert? Yes or no? Did they order a dessert? So I think this is confidence interval for 2 independent proportions. All righty then. Let's go to the next page. Here we go. So let's do number 6. So here we go. Let's see how you did. Oh, you know what? I think this was kind of actually a bad problem. But it's kind of interesting to talk about what's not so good about it. So it says, are people more likely? So let's see, to die of a heart disease or cancer. So I'm thinking that it's not asking me how much more likely. So I'm not estimating an amount. Okay, so I think confidence interval's out. So it's a hypothesis test. Okay. They analyzed 20,000 death certificates. So, like, how does this work? I mean, so this I really struggled with. So I'm thinking, how would that work? We're going to take these 20,000 certificates. I'm going to go, okay, I'm going to look at the cause of death. And I'm going to go, okay, I'm going to put them into died from a heart attack, died from a cancer, and then died from something else. Is that how that works? I guess. And then I'm going to take all of these over here and say, what proportion of the 20,000 died from heart disease or heart attack, heart disease? Okay, and then what proportion of the 20,000 died from cancer? And then the rest of those are over there. Okay, so I'm thinking it's going to be what? Hypothesis test for 2 proportions. Now, but so that's what I called it, a hypothesis test for 2 proportions. But just FYI, there is a fundamental flaw to this. Those are actually not 2 separate independent samples. You would need to take like a sample of 10,000, random 10,000, and see what proportion of those die from heart disease, and then random sample of these 10,000, what proportion of those die from cancer. You'd have to have 2 independent samples. So maybe we could do that with that first, is take those and then just randomly split them in half, and then do the proportion for heart disease and the proportion for cancer, because they have to be 2 independent samples. Because if they're not independent, think about it. If this happens to be heavier on the heart disease, then it's going to be lower on the cancer. So they're kind of like connected. Um, anyway, so kind of strange, but some good discussion that comes from that. All right, let's see how you did on number 7. Oh, how many fewer calories? So we're estimating an amount. Okay, do vegetarians consume compared to meat eaters? Okay, so I'm also thinking caloric intake is an amount, a quantity. So I think I got means going on here. How many fewer? So that's going to be an estimating an amount. So confidence interval means I got 90 vegetarians and 90 meat eaters, carnivores or whatever, herbivores, I don't know. So I guess not herbivores. What are the ones that eat both? I don't know. So there we go. I said confidence interval for 2 means. Okay. I think there's some more like 8, 9, and 10 or something. So try those on your own. Pause. Let's just discuss amongst yourselves, and then let's see how you do. All right. So pause. All right. Let's check and see how you did. Is a computer without virus protection more likely to get virus than a computer without virus protection and with virus? So we got 400 computers without, 700 computers with. They were used for, and then what would we be getting? The proportion of them who got a virus. So I got 2 separate independent samples. I'm going to do the proportion who get a virus, and I'm not estimating how much more likely. I'm just saying, is it more likely, yes or no? So that's hypothesis test for 2 proportions. Okay, number 9. Let's see here. How much does proper lighting improve museums? So how much? Okay, so that's an amount. Let's see. Visitors were asked to rate the museum on a scale from 1 to 10, both before the new lighting was installed and then after the new lighting was installed. Okay, so that means me as a person gave a rating before and after, so my opinion is going to be just compared to my own opinion, so I'm paired. So I got paired. Okay, plus it's a numerical value from 1 to 10. Okay, so that's a quantity. Thank goodness, because you can't pair proportions. You can only paired means. So I'm thinking paired data. Okay, but is it a hypothesis test or a confidence interval? Are we saying is it better afterwards? Or are we saying how much better? Looks like we're saying how much better. So that's an interval estimating an amount. Confidence interval, paired data. All right, number 10. You have conducted a survey with favored nuclear power plants. Determine a likely range of values. Okay, that's easy. That's going to be our confidence interval for the true percent of Americans in favor of the proposition. So that's going to be the proportion in favor. One proportion. Okay, that's easy peasy. What do we got? Confidence interval for one proportion. Okay. Looks like there's a number. Well, how many do we go to? Is there 13? Okay, cool. So finish it out. Do 11, 12, 13. Pause, and then we'll check. Okay? Pause now. All right. Let's see if you're getting better at this. Oh, man, that was easy peasy. Make a confidence interval on the average online statistics. Okay, so now hold on a second. So it's the interesting thing of this one is it contained percentages, but that was a percent score. And so then they gave an average score of the 45 random. Okay. So they had a claim of 83%, which actually has nothing to do with this problem. They take one sample of 45 and then make an interval to find the average score from that point estimate of 77. So that is a confidence interval for just one sample, and it's a mean because it's an amount. Yeah, also tricky because it is a numerical score. You're getting that average percent. Okay. 12. Do people make more money? So yes or no, compare the 300 living in houses to the 300 living in condos, and we're talking money, so that's a quantity. So I've got two independent samples. Do they make more money? So is this one greater than that one? Yes or no? Hypothesis test for two means. And finally, what proportion of car accidents cause serious injuries? So I just had one sample, and I guess we're going to do the proportion that are serious, but I'm estimating that proportion amount. So one proportion, estimating the amount, confidence interval, one proportion. Okay, so hopefully you can figure out type of data. Quantity, is it a quantitative or categorical, proportion or mean? Okay, and then how many samples? One sample, two sample. If it's a mean, is it paired? Okay, and then are you estimating an amount, a confidence interval, or are you seeing if you have evidence that one is different or more or less or than the claimed? All right, that's a hypothesis test. So good luck to you. Let's see how you do on your assignment. There's 20 of them for you to try.